In this video, we're going to look at the examples in the 3-1 slides. We're going to start here on page 4, where we're asked to decide whether each of the statements is compound and to identify the connective in each statement, if so. So we'll start with this statement. Lord Byron wrote sonnets, and the poem exhibits iambic pentameter. This is a compound statement because it has two statements in one. Lord Byron wrote sonnets is one, and the poem exhibits iambic pentameter is the second. The connective here is and. And is not always a connective. It depends on whether it's connecting two statements or not. Next, we've got you can pay me now or you can pay me later. And again, we have two statements with a connective. The two statements are you can pay me now and you can pay me later. The connective, of course, is or. The third one is also compound. Its two statements are it's on the internet and it must be true, which of course we all know is false. And the connective is more than one word here. Our connective is if then. Finally, we have my accountant works for Ernst & Young. This is not a compound statement. We have the and, but it's not connecting two statements. It is setting up this company, Ernst & Young. That is one company. It's part of the given statement. We'll move on to the next set of questions. Here we're asked to form the negation of some statements. Okay, so the first statement that we have to negate is that city has a mayor. This is a very simple negation. That city does not have a mayor. Then we've got the moon is not a planet. The negation there is the moon is a planet. Very simple. Next. In our next example, we're asked to give negations of these inequalities and not use slash marks for them. So when we're dealing with the negation of something like this, we have to account for all possibilities. If x is less than a, then the negation is not simply x is greater than a, because there's another possibility. If x is equal to a, it is also not less than a. So the negation of x is less than a is x is greater than or equal to a. For 7x plus 11y is greater than or equal to 77, the only possible thing that could make this false is if 7x plus 11y is less than 77. Oh, okay. Next up, we're asked to let P represent the statement informatics is a growing field, and Q is the statement critical care will always be in demand, and we want to translate these statements from symbols to words. So we're starting with the statement P or Q. Well then, that's equivalent to informatics is a growing field, or critical care will always be in demand. not P and Q. Well, that means informatics is not a growing field, the negation of our P statement. And critical care will always be in demand. Next, we've got not P or Q. Now, we've got that in parentheses, which means we're saying that that it's not the case that P or Q is true. Well, then that means here, and we'll look at better ways of dealing with this coming up, but for the moment, the best way we can write this is, it is not the case. It is neither the case that informatics is a growing field, nor critical care will always be in demand. Finally, we've got this one, not P and Q. And again, the P and Q is in parentheses, which means that we're negating the P and Q statement. So we can write this case, we can write this as it is not the case that both informatics is a growing field and informatics will always be in demand. Next, where are we? Negation of each of these statements. Here we go. So we need to form the negation of each of these statements. Okay, so first we want to negate the statement that some cats have fleas. The negation of this statement means that there are not some cats that have fleas, so there are no cats that have fleas. If we want to negate the statement, some cats do not have fleas, then that implies that every cat has fleas, or all cats have fleas. Finally, if we want to negate the statement, no cats have fleas, well, we can't say necessarily that all cats have fleas, but we can say that some cats have fleas. All right, moving on to the last slide of the set. We've got this last example. We need to decide whether each statement involving a quantifier is true or false. So the first statement is there exists a whole number that is not a natural number. Well, for this, we consider what are the whole numbers and what are the natural numbers. What's the difference? And the statement, we know that the definition of whole numbers is it's the natural numbers plus the number 0. Since 0 is a whole number but not a natural number, this is true. Next, every integer is a natural number. That is not true because 0 is an integer and is not a natural number. The same can be said for -1, -2, and so on. So this is false. Next, every natural number is a rational number. Okay, so we consider, are there any natural numbers that are not rational? Are there any natural numbers that we can't write as a fraction or ratio? And no, there aren't, because every single rational number can be written as a fraction by just putting itself over 1. So this is true. Every natural number is a rational number. And finally, there exists a rational number that is not real. I think it's actually supposed to be an irrational number. We can go back and look here. There exists an irrational number that is not real. Well, if we look at the definition of irrational numbers, we get x such that x is a real number and x cannot be written as a quotient of integers. But the important thing here for our purposes is x is a real number, which means that every irrational number is real, and this last statement is false. That's it for this video. If you have any further questions, please get in touch.